Advanced Math ladies, this is lesson 1.5 part 2. We need to start with problem number 17, which says the length of each side of a square is 3 inches more than the length of each side of a smaller square. The sum of the areas of the squares is 149 inches squared. Find the lengths of the sides of the two squares. So it says we have a small square and we have a large square. And mine don't look super square, but they're squares, because I said they were. Anyway, on 17 it says the length of each side of a square is 3 inches more. So if the side of this square is x, because we don't know what it is, but this one is 3 inches more, so this would be x plus 3, and both sides would be x plus 3. And it says the sum of the areas. Well, to find the area of a square, you do length times width, or base times height, whatever you want to call it. So the area of the small square plus the area of the large square is supposed to be equal to 149 inches squared. So the area of the small square is just x times x, which is x squared. And the area of the larger square is x plus 3 times x plus 3. Well, if we FOIL that out, x times x is x squared, x times 3 is 3x, inside is 3 times x, which is 3x, and 3 times 3 is 9, equals 149. Now, let's do some like term combining. X squared plus x squared is 2x squared. 3x plus 3x is plus 6x, plus 9 minus 149. When we combine those, we have 2x squared plus 6x minus 140. You can do AC factoring with this as written, but if you notice, 2, 6, and 140 are all even, so we can divide everything by 2 and have an equation with smaller numbers for us to work with. So let's do that, and that gives us x squared plus 3x minus 70 equals 0. In this case, A is 1, C is negative 70, so AC equals 70. And so 1 times 70, 2 times 35, and like we've done earlier, I'm going to skip down to the heart of the matter, and so we would be using 7 and 10. In order to get the plus 3, we would have x squared plus 10x minus 7x minus 70 equals 0. The common factor, let me build a wall down here. The common factor for the first two is x, which leaves x plus 10. The common factor for the second two is negative 7, which leaves x plus 10. Then the common factor of both is x plus 10, which leaves x minus 7. So x plus 10 equals 0, says x is equal to negative 10. X minus 7 equals 0 tells me that x equals 7. Obviously, a square can't have dimensions with negative numbers, so this answer is out. So then, this square is 7 inches by 7 inches, and this is 7 plus 3, which is 10 inches by 10 inches. So, how do you want us to write the answer, miss? I'm going to erase some of this so that we have a little bit of room, so that we still have the picture on the same page with us. I would say small square, 7 inches by 7 inches. Large square is 10 inches by 10 inches. And that will be considered beautiful. Okay, now let's look at number 22. The problem says a landscape architect has included a rectangular flower bed measuring 9 feet by 5 feet in her plans for a new building. She wants to use 2 colors of flowers in the bed, one in the center, and the other for a border of the same width on all 4 sides. If she has enough plants to cover 24 square feet for the border, how wide can the border be? Okay, let's go back and dissect that. She has a rectangular flower bed that is 5 feet by 9 feet. Well, looking at the picture, one's got to be 5 and 9, but from the picture, I would have to say this one's 5 feet and this one's 9 feet. She wants to use 2 types of flowers, one as a border and then the other in the middle. And it says she has enough plants for 24 square feet for the border. How wide can the border be? Let's call the border X. That means this distance is X, this distance is X, this distance is X, this distance is X. So when we look at the area of the whole thing, because squared indicates area, the area of the large square minus the area of the small square, this is very similar to the one we just did, is going to equal 24 square feet because that's going to be the border part. If you take the big square, subtract out this part, then all that's left is the border. Well, how do we do the area of the large square? It's 9 times 5 minus, now the area of the small square is a little bit trickier, but I'm confident you can do this. If this whole thing is 9 and we're taking x off of each end, then that would be 9 minus 1x minus x, which would be 9 minus 2x. And if this is 5 and we're taking off 1x and 1x, that's 5 minus 1x minus 1x, which would be 5 minus 2x. And then we still have equals 24. Now we're ready to do some cleanup. 9 times 5 is 45 minus, and when we do this math, 9 times 5 is 45. 9 times negative 2 is negative 18x. Negative 2x times 5 is negative 10x. Negative 2x times negative 2x is plus 4x squared. Equals 24. Okay, we need to distribute that. So we've got 45 minus 45 plus 18x plus 10x minus 4x squared, because we have to distribute this negative throughout the brackets, equals 24. When we combine like terms, we've got negative 4x squared plus 28x, and the 45's cancel, equals 24. Okay? Sorry, I ran out of room on that page, so I have to go to the next page. Okay. In order to solve this, we need to put everything on the same side, so we'll subtract 24 from both sides. So now we have negative 4x squared plus 28x minus 24 equals 0. Just like in the earlier problem, all of these will divide by 4, so let's divide everything by negative 4. So now we have x squared minus 7x plus 6 equals 0. To do AC factoring, A is 1, C is 6, so AC is 6. The factors of 6 are 1 and 6, 2 and 3. Well, which one of those will add and give me 7? The answer is 1 and 6. So then we have x squared minus 6x minus 1x plus 6 equals 0. Taking out the common term for the first two is x, which leaves x minus 6. Take out the common term for the second two, and I've always told you if that's a negative to take out a negative, so let's take out a negative 1, which leaves x minus 6. Then we have a common factor of x minus 6 times x minus 1 equals 0. So x minus 6 equals 0 when x equals 6. X minus 1 equals 0 when x equals 1. These are our two options for the width of the border. This answer with 6 cannot be an answer because the width of the original was only 5 feet, so there's no way I can have a border of 6 feet. So then our answer is x equals 1 foot wide would be our border. Okay, now let's look at problem number 23. 23 says a rectangular piece of metal is 10 inches longer than it is wide. Rectangular piece of metal. We don't know how wide it is, but the length is 10 inches long. Squares, which means they're the same length on all four sides, with sides 2 inches long are cut from the four corners. So we're going to cut a square out of each corner. And each side of the square is 2. And when we do that, the flaps are folded upward. We're going to fold on the dotted line. When you fold it on the dotted line, you will have a box. And it may help you to take a piece of paper and cut the four corners out and fold it up to see what we're talking about, if you struggle with seeing what we're doing. But anyway, it says the volume of the box is 832 inches cubed. What were the original dimensions of the piece of metal? To find the volume of a cube or a box or a rectangular box or whatever you want to call it, we always do length times width times height. Some places say the area of the base, which is the length times width times the height, but they all get us there. So we need to know the length. If you look at this, this is x plus 10 for the whole thing, but we're taking 2 inches off of either end. So 2 plus 2 is 4, so we're going to subtract 4 from this, so that would give us x plus 6 for the length. Then to do the width, this was the original width, but we're going to take 2 off of each end. So that's going to be x minus 2, which would be x minus 4. Here's the part that some students have a hard time seeing. They are asking how tall the box will be. Well, if I cut the square out, and stand it up, that means the height is going to be 2. So then our volume is equal to 832. Well, the first thing I'm going to do, just because I'm like this, is I'm going to divide both sides by 2, because when I see a number like 832, I get nervous. So let's FOIL this. X times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x. 6 times negative 4 is negative 24 equals, and 832 divided by 2 is 416. Before we can solve it, we have to put everything on the same side. So let's subtract 416 from both sides. And we have x squared minus 4x plus 6x is plus 2x minus 440 equals 0. To do AC factoring, we've got to find the factors of 440. 1 times 440, 2 times 220, but for sake of time, I will tell you that those two numbers are 22 and 20. So then we have x squared plus 22x minus 20x minus 440